Hello and welcome to this webinar, Linked Data, Graph Data Model as Alternative. The motivation behind this webinar is that I've given workshops numerous times over the past years where I used much of the material in this presentation, and now I decided to bring this all together and create one presentation which is very generic but for everybody to learn something about linked data and graph model technologies. The idea is not to go extremely in-depth, so by no means it's a full explanation of everything that can be done. So some of the linked data enthusiasts and the RDF enthusiasts out there might be a bit disappointed, but for the people who have never thought about this process before and these technologies, it's a great introduction. So my name is Bart van Leeuwen. I'm the owner of a company called Netage, and as you can see in our tagline, we do smart data for smarter firefighters. We focus mainly on graph technology within the emergency response domain. We have been active in a lot of standardization efforts around the technologies we're going to talk about through the W3C and also through the OGC, the Open Geospatial Consortium. So we have been on the forefront of the development of these technologies. So instead of directly taking a deep dive into what graph technology actually is, I think it's really important to understand where we come from, because in my presentation slide I said it's an alternative way of data modeling. So it's an alternative to what? So let's get back to how did we start using data modeling as we know it today. And then you have to go back to the early days of the computer. So a lot of the data modeling we do nowadays is based on a historical legacy. Low-level computer operations were expensive and slow. And the way that computers addressed memory in the beginning of time, when they were just developed, needed that the programs to be created to do this efficiently as possible. So memory for a computer is more or less a matrix. And if you look at the matrix at the screen, if we want to go to the orange 4, the computer has to address it by a row and a column number. And practically this is still valid nowadays, that the computer needs to point to a specific point in memory. In the old days, the switching between rows and columns was very expensive. So a lot of the programs that we had were sort of designed to be as efficient with how the computer operated as possible, not so much to make them intuitively for the end user. So if you look at a traditional way, and what I've taken here is a data model we started creating very roughly on community risk reduction for the fire service. So visits to houses, etc., etc. So here we have a table which represents records of several house visits. And you probably have seen tables like this or Excel sheets if you like. And if you look closely, you see that there's some duplication in there. So there's a couple of lines and a couple of cells which seem like double. And if you now go back to the idea of optimizing it, what they start doing it, because memory operations and memory by itself as storage was expensive, they started looking at a way, could we sort of prevent this duplication of information in our records? And that's when we came to this part. And this is what you probably have seen in Excel sheets as well, that you've seen various tabs containing bits and pieces of information where one tab is actually pointing to the other tab in your Excel sheet. And interestingly enough, the reason that we're using Excel sheets, and a lot of people use Excel sheets as a database format, is also mainly because of the idea that if we create a program which mimics the memory, we can make it efficient. The very first incarnations of spreadsheets were only created with that in mind. So recap that. From a conceptual level, most of the data storage and the data modeling tools we use nowadays were focused on a computer optimized representation and optimized for performance because it was slow and it was expensive to use. No user interaction or user intuitively understanding what the data model was about was needed. It needed to be optimized. On a content level, most tables we use nowadays, and you see that in your Excel sheets, are organized around domain concepts. And the next one is very important. You need domain-specific knowledge to understand what is in the tables. And everybody at some point in his career got an Excel sheet where he was wondering, I have no clue what this is about. It's a bunch of numbers and rows and columns. I have no idea what this actually means. Is it all bad? No, it's very good for well-regulated domains. If you need to be very concise about the information you store. Think about banking. These kind of models are very, very important because it allows for really good checking of what's actually going on in the system, but it's not very flexible. If you want to change the model, and people who have been through this know this problem, changes in the data model have a high impact because there is a tight coupling between the application that uses the data and the data storage. You need the application to make you understand what the data is about. So if you change anything in the data model in the back end, the application probably won't work anymore. If you go to really large amounts of data, the complex models perform really poorly. And the reason that the Googles and Facebooks of this world moved away from traditional data modeling is because they could not make this perform anymore. And the second part is obviously every concept in your domain you want to model needs a separate table in this approach, which is very limiting. You can get around that with having sort of multi-value fields, but then you need more complexity in your application, which brings you back to the first point. If you're going to change anything in the model, your application doesn't work anymore. So this is what we all are accustomed to. We all have these spreadsheets, we all have these databases with tons of tables, which make it very hard to get your information out, and you need a system specialist to actually understand what's going on. And is that the only problem? Now there is another issue, because we talked about this briefly. If you look at this, this excerpt of this table, you'll start to notice that some of the things in orange are pretty vague. So what does the location mean here? What does the name mean? What does the date mean? Is the location an identifier, and what does the identifier point to? The name, is that the one who created the record or the one where we actually had the house visit? And the date, for the US people on this view, you'll probably have a different opinion about the date than I have from a European perspective. And also the advice given, is this concise? Is there a sort of a script we have given, or is this something that people just said you need to do this? This is what I talked about with the Excel sheets, that you get Excel sheets with information in there and you're really like, I have no idea what this actually means. So we need to take another step when looking at data modeling like this. So we need to talk about encoding standards for dates, times, and locations, that everybody understands what the location, times, and dates are. And we need to talk about taxonomies, terminology, and definitions. What do the terms in our data mean, and what is the definition for that? So that when we exchange this information, people start to understand what we talk about instead of assuming that they understand what we talk about. So now that we've seen two problems, that the data model formats we actually use is more computer optimized and it's easier for us to understand, and that in the data itself we need to have really proper way of encoding what we mean with the data, can we take a different approach? Can we do it completely different? So let's look at this except of this table we've created before, the data model. We're talking about a specific house visit here. If you want to share this information with people, just throwing them a set of Excel sheets with this information in there, it's very unlikely they will fully understand it, because they have to make the connections between what everything means, and you have to hope they understand it. But what if you create a narrative out of this? Because what you actually done is on October 9th, 2018, we performed a house visit, record number HV1 with truck 1, which has a crew of 3. We went to the John Doe residence at 10,145 and advised to install a smoke detector and a CO detector. It's much more likely that people will actually remember this story than they will remember the contents of this Excel sheet. And why is that? Well, this is because what we've done here with the narrative is how we communicate as humans instead of throwing tables. And probably there are some people out there who love to communicate in Excel sheets, but on the general public, we talk about narratives. We exchange stories, we exchange experiences. That's how we interact as humans. So can we do this on the data model level as well? So if we break this down, if we take these elaborate sentences and bring them back to the level of a 4-year-old. We did a house visit at HV1. It was on October 9th, 2018. We were at truck 1 has 3 people, etc., etc. Simple sentences. And we can even break this down grammatically. HV1 is house visit, HV1 was on, etc., etc., etc. So now you're making this whole more elaborate sentence in discrete statements. And And these statements are basically comprised of a subject, predicate, and object. HV1 is a house visit. HV1 was on. And if you look closely, you can actually see that a subject can be an object and vice versa, where the truck, which is an object in one sentence, becomes the subject in the next one. And the same goes for location. This is more how we communicate. This is more how we interact as humans with each other. And if you draw this out, you actually draw out the graph concept. Various nodes and edges. There is no actual start point of this story. You can start on the right side of the sheet with the John Doe residence, or you can go, okay, where did we do advise a smoke detector? And I understand that some people were thinking, hey, we have been using mind maps, and I love using mind maps. I'm not a computer specialist, but I love using mind maps to actually show what I have in my head. And why is this so resembling? The thing with mind maps is that they are associative. And everything we do in our brain is basically based on associations. It's much more likely that you will not remember my name after this presentation, but you will remember some of the features of this presentation and then can relate it back to me as a presenter. That's how your brain works. And frankly, you cannot even control how your association works. The neurons in your head will actually solve that for you. So now that we created the graph concept of a data model, we're actually creating a data model which is much more aligned with how we think. And doesn't push us in this really strict and rigid tabular format, but more in the associative format. So this is all great. So we have a data model which is more related to how we interact as humans. So it should be much easier to draw graphs, like you can draw mind maps of information and find connections between bits and pieces of information instead of analyzing tables and Excel sheets. But it's great. But we have a new format. We still have the same problems because this middle column is still ambiguous. Is a, was on, performed by, crew size, etc., etc. So even though we created the different model, which is more easy to understand for us because it uses the same way of associating information as we do in our heads, we still have this ambiguity on what various things means. So we need to go one step further. We need to go to a step where we can actually make sure that when we use this model, people will be able to understand exactly what we mean. So we need to talk about unique identifiers. And this is not a shameless plug for my business card or for myself. This is a question. What on this business card is a unique identifier for me? And especially the people from the Netherlands who tuned in, Bart van Leeuwen by no means is a unique name in the Netherlands. Go and Google it and you'll probably not find me on the first 5 pages. So what is a unique identifier here? If you look all the way at the bottom, you see my LinkedIn profile. And unless my profile gets hacked, which happens nowadays, this is a pretty unique identifier. This URI on my business card points to me. So if you have seen this presentation and you think, hey, I know somebody who needs to talk to this Bart van Leeuwen, instead of having him to search for Bart van Leeuwen on LinkedIn, you can actually point them to this location and he will certainly get to my LinkedIn page. And interestingly enough, this concept is what we use on a day-to-day basis. If you go to your online banking, you use a URI you trust. If you go to a news site, if you go for an airline, if you go for a certain hotel brand, you use the URIs of these brands to go to these places. So they're unique identifiers and they also gave some sort of authority, and we get back to that point later. This means that if you say, oh, you need to fly a certain airline with this web address, the other person who receives this information unambiguously understands that it is about this specific airline, because if he looks that URI up, he will see it's that airline and not something that he might have heard or he misunderstood you. It's a unique identifier. So why not use that in our data model? So put the URIs on predicates. And in the middle you see the predicates, and I shortened them, otherwise the slide would have become unreadable. I truncated them a bit. The idea is that if you start using this, and you could potentially look up some of the URLs on the web to understand what this predicate actually means. What are the constraints of this predicate? Anybody who uses the same predicate is actually using the same, meaning the same thing. If you have a different opinion about a predicate, you just create a new URI and you make sure that you know that, well, this is not the same thing as the other. And systems can help you determine, well, the wording is the same, but the meaning is different. So this is how we create unique identifiers for our predicates. And why not just do unique identifiers for everything? So we have the records management system with the identifiers for the house visits and the trucks, etc. The predicates and also the objects here and there have URIs. Sometimes it's just a plain literal because, well, the number 3 you cannot create a URI for that. Technically you could, but that's a whole different discussion. We're not going to go in there. And essentially in the middle of this we talk about our data model. So this is how we model this graph model, because this is where we determine what these connections actually mean. This is how these nodes on the graph actually connected and what the meaning of their connection is. And did we come up with this by ourselves? No. This is actually the resource description framework, which is a horrible term, which is misunderstood by a lot of people. The resource description framework is a framework, so it's not a file format. So people say, oh, give me an RDF file. There is not a single format on how you can express RDF. It's more a way of thinking. And what we personally, as Netage, find super interesting is that it's multilingual by definition. That this is one of the few file formats who can do multilinguality inside the model directly without going through all sorts of burning hoops. And you can serialize it. You can create files of it. And the most prominent versions are Turtle, which is more or less human readable, JSON-LD, which is usable for application developers, and Triples, which is a super fast streaming format, but still complicated. And then it's in gray, RDF XML, and this is where RDF got its bad name, so please don't use that anymore because it's very cumbersome and it makes people quiver when they see the file format. So this is all standards based, comes by the W3C, and this is the way of expressing graphs through URIs. The idea of using the RDF framework comes back from when we started thinking about artificial intelligence to make the web smart. And to go into the direction of artificial intelligence, you need to have to understand two concepts, which are also important in creating your data models in graph technology. It's the open and closed world assumptions. A closed world assumption is to answer all all data to answer the question is available in a system. And that's, for example, your bank statement. You really want to make sure that if you ask your bank, what's my account balance now, that all the information to need to answer this question is actually available at that time, and that it's undisputed. This is your balance at this point in time. But if you think about more broad concepts, and that's where the open world assumption comes in, it might be that the answer or the information needed to answer your questions might not be all available, or it might be unknown. So an answer might be, well, we're not sure. As some people know, I'm a firefighter. Am I the only firefighter who likes to talk about linked data? Could be. In the meantime, I've met a couple, but still, there's so many people out there that this is, well, an open world assumption. I'm not sure that I can answer this question. If you're going to create data models in the graph model, you have to be aware that how you create your data models have to keep this in the back of your head. If you're going to create models, there might be information out there you're not aware of right now, but which is still relevant to what you're going to model in your graph model. For starters, this is something you might want to skip immediately, but this is an important thing if you start thinking about graph modeling. So if you look at what a data model is, and if you go into the RDF concepts, we're actually talking about vocabularies and ontologies. Almost a religious dispute on where the actual limit is. I just decided to leave it at that. It might be something for a next webinar. Vocabularies and ontologies allow you to bring intelligence on the web. They allow for reasoning and inferring statements, and you can even do detection of errors with that. Although there is a new technology for that, it's data shapes, which you can do to validate some of the graph data models. So how does that work? So if you say simple reasoning, if you say, well, crew is an element of apparatus. So in our data model, the only thing we've written down is truck has a crew of 3. We haven't said anything about what truck actually is. But through reasoning and inferencing, we can say, well, if something has a crew predicate on it, it's actually of a type apparatus. So even though this information is not in your data, you could actually ask which apparatus went to what house visits, and the system will be able to answer that because in the intelligence, in the vocabularies, or in the ontology, it's noted that this is how this is organized. And the same goes for, okay, you could reverse it. And that's sort of the father-son principle. I have a father, my father has a son, so these are interchangeable. So they're reversed off. So you could actually say a truck is a type of an apparatus, but that also means that the truck visited the house visit. He did the house visit. So if you go from one direction to the other, you'll actually have the arrows both directions. The fun thing is you don't actually have to record this in your data system, but your reasoning and inferencing engine can actually create this information on the fly, and that is super powerful. You can do super wild things with that. So now that we've covered what a graph model is, how that looks, and what you can do with it, and how you can basically move that into an RDF perspective, let's take the next step. Let's talk about linked data, because that's what I started this conversation about. So what is linked data? And a former W3C staff member created a excellent tweet about that, and mind you, this was in the short tweet period. Linked data uses concepts and technologies of the web to describe the world, and he was proud that he could actually add no acronyms, no tech terms, one tweet. So that's cool. That's actually what it is. But what do we actually mean with that? So let's go back to what the web is. And this is a great document. This is sort of the blueprint of the web. It's a thesis from somewhere in the late 80s, and you can see it up here in 1989. Information management, a proposal by Sir Tim Berners-Lee, or is actually Sir now, not at that point, Tim Berners-Lee, and his professor wrote on that, vague but exciting. He came up with a method of organizing documents on a computer network in a way that it would be much more easy to find and navigate documents. And if you look at his initial schema of how this should be done, you recognize a graph. And come to think of it, the way we use the web, and not the applications, but the web by itself, is more or less a graph. Because if you go to Wikipedia, there is no start page of Wikipedia. You go to a movie and then you browse from a movie to actors, to cities, to other actors, to other movies. And from these cities you might go to the famous bars of other people who live there. There is no starting point, there is no end point, and you'll just hop from page to page. Most of you probably got lost on the internet on a rainy evening just clicking through things. The same goes if you read news articles. You go from one article to the other article, background articles, or websites of companies mentioned in these articles, etc., etc. It's the whole idea how this should work. So even the web as we use it today is actually a huge graph. The only thing is that we still need humans to interpret all this information. So linked data tries to do that on a data level for computers, a web of data. So concepts and techniques of the web. Contextual links between documents through references. Like on the Wikipedia page, you see the name of an actor underlined, you click on it, and you know you will go to his page. The link itself contains information because, well, it knows which actor you go to, and the target link, so the page you retrieve, actually contains information again because it other movies, his spouse or his spouses or whatever. The technology behind it, it's an unlimited amount of locations. You never know where this web page is unless you created them yourself and you know exactly on which computer it is. But in general, as a consumer, you have no idea where this information is. And more specifically, you do not need to have the knowledge on how to reach it because the web solved that for you. You use a URI and it is resolved for you. You don't need to have the technical knowledge to get to that point. So what does linked data actually do? So we use URIs to identify things, and we did that in our example. We use HTTP URIs to be able to load this data from the web. That's what I said in the middle column. If you put these predicates, these vocabularies on the web, people can actually click on these links and then find what the predicates actually mean. And if somebody requests a URI, make sure that it gives back information which is relevant in a format that it can understand. So the best practice is if you, as a human, open a linked data URI, you get some form of readable information, but if a computer program will do it, hopefully they will get back JSON or something like that. And make sure that if you provide this information, your information is actually linking to other bits and pieces of information. That's the whole idea of linked data, because then you'll end up with creating a web of data which is usable. So what are the advantages of linked data? Obviously there's metadata in the data, because in the data is what the predicates actually mean. And if you don't understand what they mean, you can look them up because they are dereferenceable on the web. A very important aspect is that it's reference data. Because your company name or your institution name might be in the URI, it gives you authority and it allows you to have data at the source. The Dutch cadastre, for example, has a URI for every house. You can look up the URI of your house if you know it, obviously, but there you find authoritative information. The data is at the source. The organization who's responsible for the information publishes it at the web and where you can find it. You can use uniform identifiers. So the URIs, if you use them through data sets, as long as a data set uses the URI of my house, I can connect all these data sets together if I have access to them. It's machine readable, so the machine, there is tons of tools, open source tools to make sure that people and machines both can extract this information. And it's ideal for data exchange because it's all free and open standards. And our personal favorite of the linked data principles is that it's super agile. We've created so many quick applications where we started with very few statements in our linked data, small graphs, and we're able to extend the graph extensively without breaking any of the applications we have created in the meantime. So we've looked at RDF, and this is what linked data would actually look like. Practically, this is the N-triples format. And this is not human readable, but computers can do fantastic things about this. So this was a brief and high-level introduction of what graph data technology is and what linked data is and how this is all combined. And we think this is a really vital technology to do all this massive data integration that is needed to make society move smoother. So recap, we talked about graph data model, where we go from the more traditional computer-based model, which was only created out of optimizations, to a more graph model-like way of dealing with information, which is more what we use in our heads. We talked about the mind maps, because we talk about associative relations. We talk about open standards. We talk about reference data. We talk about uniform identifications of resources. And it's super flexible. It's super agile, because you can really exchange information quickly, and you can enhance the data model without breaking any previous applications using this. So I hope you liked it. I hope you find it informative. And I would like to say thank you for watching this webinar.